Hello everyone, welcome to video lecture of Advanced Manufacturing Technology. I am Manu Joseph, Assistant Professor, Department of Mechanical Engineering, Rajagiri School of Engineering and Technology. In this lecture, we are going to discuss about Material Addition Process Part 2. In Material Addition Process Part 1, we have discussed about rapid prototyping and different methods of rapid prototyping, and we found that rapid prototyping is a technique of producing the model or prototype quickly from design or CAD design or computer designs. And we found different techniques, some of the techniques in the previous lectures like stereolithography, selective laser method, fused deposition modeling and laminated object manufacturing. In this lecture, in the part 2, we will be discussing about some more models, some more methods of rapid prototyping. So, an overview. We will discuss in this lecture, we will be discussing about laser beam welding, laser engineered net shaping, 3D printing and Liga process. So first is laser beam welding. From the name itself, it's clear that it's a welding, and then the heat source is laser beam, and we also supply certain inert gas through. Here, welding technique used to join piece of metal or thermoplastics through use of a laser. Here, laser we are using as a heat source. Beam provides a concentrated heat source, allowing for narrow, deep weld and high welding rate. So, welding rate is very high and also narrow weld. Okay, based on keyhole or penetration mode welding. The process is frequently used in high volume applications using automation. High volume application, we are going to use this with the help of automation, such as in automotive industry. The application to produce micro weld, dissimilar material welding, we are using this technique. So that is laser beam welding. Here we can see the image, a laser source, workpiece, then we can see a nozzle through which a jet of laser is coming, and then we have a gas source, inert gas source also there. Next is laser engineered net shaping lens. Here also, this is also a rapid prototyping additive manufacturing process. Instead of laser welding, here we have a powder material supply along with laser source. So what happens is, due to this laser heating, the material addition, the material melt and addition take place. The process is like another rapid prototyping technology in its approach to fabricate solid component by layer additive method. So it's additive process. Laser create a molten pool of metal on the substrate. Suppose we have a substrate and laser create molten pool of metal into which powder feeder inject additional powder. Here in the image we have seen separate powder source along with laser heating. The metal powder rapidly solidifies, forming lines of deposited material on the substrate. The lines are sequentially deposited adjacent to one another until an entire layer is fabricated. These layers are sequentially deposited until the entire layer is fabricated, or entire solid object is fabricated. Laser focal point is then moved in the positive Z direction to begin the depositing the next layer. An inert gas is used to shield the metal from atmospheric gases. So inert gas source is also supplied. So here we can see a nozzle or inlet, and also a supply for powder material, and also an inert gas source here. Then laser beam. Okay. So that's about laser engineered net shaping. That is, process is like rapid prototyping technique in this approach to fabricate solid component by laser additive manufacturing. Laser create a molten pool of metal on the substrate into which powder feeder injects extra powders. Metal powder rapidly solidifies, forming lines of deposited material on the substrate. This gets solidified and this process continues to get the final product. Next is 3D printing. 3D printing. So this next is 3D printing. So 3D printing is a form of additive manufacturing technology where a three-dimensional object is created by laying down successive layers of material from a digital file. So from the digital file, based on digital file, laying down successive layers of material is laid down. Each of these layers can be seen as a thin sliced horizontal cross section of the eventual object, the final object. So each of this layer can be seen as a thin sliced horizontal cross section of the final object. So we can see a number of components produced using 3D printing. Okay, it's also an additive manufacturing process. So modeling, 3D printable model may be created with a computer aided design, CAD package via 3D scanner, or via plain digital camera and a photogrammetry software. 3D scanning is a process of analyzing and collecting digital data on the shape and appearance of a real object. Based on this data, three-dimensional model of scanned object can be produced. Based on data, we will get three-dimensional model. That's the modeling. Then printing. Before printing, 3D model from an STL file, it must to be examined for any manifold errors. This step being called fix up. So first we will do fix up from the STL file. Especially STLs, that is standard triangulated language, that have been produced from the model obtained through 3D scanning often have many manifold error in them that need to be fixed. That's the fix up process. So STL file, it consists of number of manifold errors that should be fixed up. The STL file needs to be processed by a piece of software called slicer, which convert the model into a series of thin layers and produce a G-code file. It produces a G-code file containing instruction tailored to specific type of 3D printer. So it creates a G-code from the STL file. Okay, this G-code file can then be printed with a 3D printed client software, which load the G-code and use it to instruct the 3D printer during 3D printing process. So that's about 3D printing. So we have a model that should be sliced, or that should be converted to STL file. STL file has some errors that should be fixed up. After fixing up the errors, we should convert that to, or we should slice it to number of layers and then convert it to G-code. Then that G-code will be supplied to 3D printer, which print the G-code. So that's about 3D printing. We can produce number of components using this 3D printing. Next process is Liga process. Liga process is used to manufacture microstructures by deep X-ray lithography. By using X-ray lithography, we are producing components. That process is called Liga process. So this is the first process. We use X-ray. Previously we are using laser beam. Here we are using X-rays. Using the process, microstructure can be manufactured from different plastic materials and metals. Manufactured using different plastic materials and metals. Liga consists of three main processing steps. So lithographic process, electroforming or electroplating, then molding. These three processes constitute Liga process. So lithography, electroforming or electroplating, then modeling. This represents a Liga process. The process starts from here. Here we have a substrate over which we have a PMMA cast. Then we keep a mask. This is a mask. And that over the mask, through the mask consists of the shape that's to be produced. So when it is radiated, so deep X-rays, powerful X-rays, we can see. So by chemical reaction, material removal take place. The material removal take place in the PMMA, polymethyl methacrylate. It's a polymeric material. So that will act as a mold. So we can electroplate through PMMA. We can do electroplating through PMMA. So then our purpose is to remove this PMMA. This is our required product. So separate metal from the PMMA is the last stage. So this is Liga process. So first we have a cast PMMA. We cast PMMA on the metal surface. Then we mask it, cover it to required shape, and supply X-ray radiation. The X-rays get masked by the mask, and it will be allowed to fall on the required region. Region where X-ray falls, decomposition take place, we will get a cavity like this of required shape. Then we perform electroplating on this PMMA surface. So we will get the material inside. Then we remove or separate the PMMA by some chemical treatment. Finally, we have the final product. That is Liga process. So step involved: apply resist and X-ray exposure through mask. So preparing the PMMA over the metal plate. And we apply X-ray through a mask. Remove exposed portion of the resist. So as a result, chemical decomposition take place and exposed portion of the resist will be removed. Electro deposition to fill opening in the resist. Strip the resist for mold or metal part. That's the final stage. So here we can see PMMA on a nickel substrate. PMMA is polymethyl methacrylate, polymeric material. Then we'll have the mask. Then it's irradiated with the X-rays. So decomposition take place where X-ray irradiation happens. And then we fill that with material through electroplating. Then we remove this resist PMMA to get the final product. So that is Liga process. In this process, X-ray sensitive polymer photoresist, typically PMMA, polymethyl methacrylate, a transparent thermoplastic bonded to through an electrically conductive substrate, is exposed to parallel beam of high energy X-rays from a radiation source through a mask partially covered with a strong X-ray absorbing material. So we have a mask is a X-ray absorbing material. The chemical removal or chemical decomposition, chemical removal of exposed photoresist result in a three-dimensional structure. The region where the X-ray is acting, the chemical removal will take place, decomposition will take place, which can be filled by electro deposition of metal. That region can be deposited with the metal by electro deposition. The resist is chemically stripped away or removed to produce metallic mold insert. The mold insert can be used to produce part in polymers or ceramic through injection molding. Okay, this mold, it can be mold or final product. This can be used as mold to produce part in polymers or ceramic through injection molding. So that is about Liga process. So material addition process advantages. So advantages of this material addition process. In last class also we are discussing about material addition process, and these are the advantages of material addition process. Accuracy and precision of the part. Then goods, because human intervention is minimum. Good accuracy and precision. Good surface finish. Model for concept verification. It can be used as model for concept verification. Suppose we have a model, we can verify it. Less time taken, fast production. Production on demand, low shortage is required, storage is required. On demand we can put, because of fast process, on demand we can produce. Wide shape and complex geometry can be made. Cost effective. Raw material are inexpensive. Simultaneous production of work is possible. Thin part can be made. That is about the advantages of additive manufacturing process. Then disadvantages. The size of the object is limited. So we have, based on the small chamber of this process, size of the object is limited. Limited raw material. Some post-processing, finishing is required here. Support requirement is difficult. Fragility of product. Part strength is weak. Temperature fluctuation during production lead to delamination. Material changeover difficult. So these are some disadvantages of material addition process. Some application. Prototype of product concept model. Functional prototype can be produced. Used for medical application products. To make models. To make whole object. Support parts, jigs and fixtures, electronics, packaging and connectors. Casting patterns can be produced. Manufacturing sporting goods. Automotive industry, to make laptop and other computers and cases. So these are some of the applications of material addition process. So that is about material addition process. So in this lecture we have discussed about some of the material addition technique. Some laser method, some laser welding, 3D printing, Liga process, and we found the application, advantages and disadvantages of material addition process. So material addition process, we found that it can be used for design verification, validation of a concept, fast production, but it having certain disadvantage. Size limitation is there, strength limitation is there. Some of the components, some support structure is difficult to prepare, but it found application in many of the field. So design field, medical field, manufacturing field for jigs and fixtures, so casting patterns, etc. So that is about material addition process. Thank you for listening.